Okay, equilateral triangles. So equi is equal, and then lateral means side, so equal sides. So equilateral triangles have three sides that are the same length. Equiangular, right? So equal, and then angular is angles. So all the angles are the same, right? Would be an equiangular triangle. So basically, all we're talking about here is that if we have an equilateral triangle, then it's also going to be equiangular. So if all the sides are the same length, then all the angles are going to be the same, right? They're all going to be congruent here. Angle A, angle B, and angle C will be congruent. And then vice versa, if the angles are congruent, then the sides are also going to be congruent as well. Okay, and the angle measure for each of these angles would be 60 degrees, right? The three angles of a triangle have to add up to 180. So we'd have to do 180 divided by 3. And that would give us 60 degrees. So all three of those angles would be 60, 60, and then 60. All right, so let's look at example 5, which is going to want us to prove that. So we'll do a little proof here for A, and then I think we got to do a second proof for B. Okay. So the first one here, prove that angle D, angle E, and angle F are going to be congruent here. So we want to prove that the equilateral triangle is also going to be equiangular. Right. Well, we notice since DF is congruent to FE by the Isosceles triangle theorem, we know angle D is going to be congruent to angle E. Okay. We also notice that DE is congruent to EF. So by the Isosceles triangle theorem, we know angle F is going to be congruent to angle D. Okay. And since angle D is congruent to both angle E and angle F, we know that angle E and angle F are going to be congruent to each other as well. So since E and F are congruent, since D and E are congruent, and since D and F are congruent, we would say that angle D is congruent to angle E, which is also congruent to angle F. All three are congruent to each other. And if we look at how they formally did that, okay, we can look at how they formally did that here. They did use the Isosceles triangle theorem twice. So if you look at the first one, right, they're going to say since DF is congruent to EF, we know that angle D is congruent to angle E. Okay, and then since DF is congruent to DE, we know that angle F is congruent to angle E. Okay, and then since angle E is congruent to angle D, and since angle E is also congruent to angle F, by the transitive property of congruence, we know that angle D and angle F are congruent. Right, and so they're all congruent to each other. Okay, and then the proof for the next one, again, would also be similar, except we're going to use the converse to the Isosceles triangle theorem. So since angle J is congruent to angle H, by the converse to the Isosceles triangle theorem, we know that GH would be congruent to GJ. And then likewise, since angle G is congruent to angle H, we know that GJ is going to be congruent to JH. Right? And since both JH and GH, segment JH and segment GH, are congruent to segment GJ, all of those segments are going to be congruent. And if we look here at the formal proof as they wrote it out, the first step was that converse to the Isosceles triangle theorem. So they put, since G was congruent to H, we know that GJ is congruent to HJ. And then they use the converse to of the Isosceles triangle theorem again. So since angle G is congruent to angle J, we also know that GH is congruent to HJ. And then since we have GH congruent to, what do we have? We had GH congruent to HJ, and we have GJ congruent to HJ. We know that all three angles, or all three sides there, all three segments are going to be congruent. That would be the transitive property. Okay, and if we look at try it here real quick. they just want you to figure out how many degrees you would have to rotate. And again, a circle has 360 degrees, so you have to use that information. How much would you have to rotate to show that that triangle, the angles on that triangle are all going to be the same?